Hello students, welcome to today's class. So our new topic for today is trigonometry basically. Uh, this chapter will be slightly lengthy, so have patience while learning this chapter. Also, this chapter has a lot of application, I'll say. Like this chapter will come in your limits, this chapter will come in your differentiation, this chapter will come in your integration, straight lines, pretty much everywhere this will be utilized. Okay, so a question may or may not be directly linked to the trigonometry itself, but idea can be used to solve any further concept. So let's start with this topic. So the first subtopic is angles. Let's study about the angles. So I'll start from the fundamental of the angles first of all. So let's draw x-axis, y-axis first of all. Okay. All right. So basic x-axis, y-axis. Okay. So how do we measure angle basically? Suppose there is a line like this. Okay. So sorry. So angle will always be measured with respect to the positive x-axis, positive part of x-axis, and it will always be measured in anti-clockwise direction. That's the basic definition of angle. Okay. So if I say angle, so we need the basic definition that it is measured with respect to positive x-axis in anti-clockwise direction. Okay, let's say this angle is 30 degree. Okay, so suppose we, instead of measuring angle clockwise, suppose there all right. So instead of measuring angle anti-clockwise, we measured the angle clockwise like this. Okay, what about that? It can be measured clockwise also, but then we have to introduce a negative sign. So here the concept of negative angle is also introduced, minus, let's say, 30 degree. I'm assuming that this angle is 30 but since sorry, since it is measured in clockwise direction, it will be negative. Okay. Okay. Let me take one more angle. Let's say I take angle here in the second quadrant. Okay. Now for that, again, remember that if we are measuring positive angle, we have to move clockwise. Let's say this angle is 120 degree. I'm suggesting the angle hypothetically. Okay, I'm not measuring it. Hypothetical values. Okay. Suppose an angle is here and I have to measure it. So for this, I will again move anti-clockwise and it will give me a positive value of angle. Let's say this angle will be more than 180. So let's say 210 degree. It can be in fractions also, like 209, 209.11 also. That value can also be there. I'm going in the integral values. Okay. So if we look at the angles basic categorization, so x-axis, positive x-axis, this itself, if I want to measure the angle of positive x-axis, so this line will be having an angle of 0 degree. Okay. If you look at y-axis, positive y-axis, if I measure this, if I measure this one, clearly you can see this is 90 degrees. So positive y-axis at 90 degree. Okay. If I take this negative x-axis, another 90 degree, that means 90 plus 90, 180 degree. Okay. If I take negative x-axis, another 90 degree, that's 270 degree, another 90 degree. So we get back originally to the positive x-axis, which was 0, but now it is again 360 degree also. So positive x-axis can be treated as 0 degree also or 360 degree also. And the whole revolution, the complete revolution is 360 degree, that we already know from the basics. Okay. So I'll erase this now. Okay. We don't need this. No, sorry. This and this. So this diagram should be pretty much clear. I'll highlight which part you should be knowing. This 0 degree, 360, 90, 180, 270. So just remember there is a 90 degree rotation. Okay, x-axis, y-axis, there is 90 degree, then another 90 degree, 180, another 90, 270, another 90, 360 itself. And we can keep revolving, and the angle actually goes more than 360 also. But if you look at the sense of angle more than 360, it is nothing but rotation. Okay. All right. Same way, I can treat negative angle also. If this is, let's say, 0 degree, this will be minus 90 degree, this will be minus 180 degree, this will be minus 270 degree, and this will be minus 360 degree if I'm moving in anti-clockwise direction like this. Okay. Okay. Usually positive angles are more important here. We'll learn how to deal with negative angle, but I hope the idea of negative angle is clear, that the whole idea of negative angle is just measured it in clockwise direction rather than anti-clockwise. So you should know this, but no need to learn this. This highlighted part should be very much clear to you. You should be able to visualize this mentally, that where is 90 degree, where is 180 degree. Okay. All right. Since the diagram is present here, so I'll talk about the quadrant itself here. Let me create some space. And I'll copy the same image so it will be easier to visualize. Okay. Yeah, that works. We don't need this now. All right. All right. Let's get some more space. All right. Let's talk about quadrants now. Clearly, your first quadrant, your angle usually is represented by theta. So theta is from 0 degree to 90 degree. Okay. Look at this. This is the first quadrant. It is between 0 and 90 degree. Similarly, your second quadrant. In this, theta is between 90 degree to 180 degree. Okay. Erase this. Your third quadrant. Okay. This is the third quadrant. This is from 180 to 270. So 180 degree to 270 degree. Okay, I'm giving it in terms of interval, more than 180 degree, less than 270. So you will be in between these two line segments, that is third quadrant itself. And finally your fourth quadrant. This is the fourth quadrant. That's between, I can say 270 and 0, but doesn't make too much of a sense. I'll increase the angle, I'll say 270 degree and 360 degree. Okay. All right. We'll use the concept of overlapping when we'll talk about the angles more than 360 degree. For the time being, let's just move in the increasing order. So 0 to 90, first quadrant, 90 to 180, second quadrant, 180 to 270, third quadrant, 270 to 360, fourth quadrant. It's as simple as that. All right. Now let's talk about units of angle. So we have two systems. Okay. Let's move it to the center. So we have 1, 2. One that you already know, degree. Pretty much familiar with that. Okay. One is radian, which now you should be familiar with, because usually the question may or may not be given in radians, or well, the examiner will prefer the question to be in radian, and the SI unit of angle, standard unit, is radian. So suppose you are solving any numerical of physics also somewhere, so for that also you need angle always to be in radian. Okay. So let's see how the conversion works. Okay. Suppose I have to convert degree to radian. I'll just use here now. We have already written now. I'll just use an arrow. So for converting degree to radian, will multiply with pi by 180 degree. Okay. And oh, sorry, 1 second. Yeah. All right. So for this we use 180 degree, pi by 180 degree to radian, and for radian to degree we multiply by 180 by pi. Okay. Let's see how this conversion system works. I'll make a table of some angles so you will be comfortable with that. I'll put lines, I think, with the angles itself. Okay, so suppose you have degree angles in here and we want to learn how to convert into radians. So I'll simultaneously convert into radians and we'll see the table itself. Okay, let's start with 0. Okay, so in order to convert 0 degree, I have to multiply by pi by 180. Anything multiplied by 0 is 0. Okay, so that is 0 degree is same as 0 radians, but in degree we have put a sign of degree, this. Okay, radian there is no sign. Next, standard angle is 30 degree, so let's convert 30 degree. So 30 degree, in order to convert into radian, I have to multiply pi by 180. Okay, and we keep our answer in terms of pi itself usually. So 30, 0, 0 cancel, and this will become 6. So basically pi by 6. Okay. Next, let's take 45 degree. Okay. So 45 degree, third one. So 45 degree into pi by 180. So that becomes 4, pi by 4. Okay, so pi by 4. Okay. Next, standard angle is 60 degree. Let's convert that. 60 degree, fourth. So 60 degree into pi by 180. That's give you pi by 3. Okay. I'm talking about only the standard angles because these are the angles you should be so comfortable that it shouldn't take you few seconds to realize which angle it is. Okay. Now, if you were very comfortable with maths as such, so you may already know these values, but I'm considering zero expectation here, so I'm teaching you from the fundamentals here. Okay. 180, 270, and then 360. Okay. Fourth one, 90 degree na. So 90 degree I've written pi by 2, but look at it, pi by 180. So 90 and this cancels, so it becomes pi by 2. 180 degree, if I convert this into pi, that's nothing but pi itself. Okay. So remember that pi is basically 180 degree. Pi in radian is 180 degree in degrees. Next one is 270 into pi by 180. So 90 into 3, 90 into 2, so 3 pi by 2. Okay, so 3 pi by 2. Sorry. All right, next one, 360 degree into pi by 180. 180 into 2, so that is 2 pi. Okay. That's it. That is the table that you need. I'll recommend that you try to learn it. I'm not saying directly that start mugging up directly these values. It's just that start with these values, the values are in the first quadrant. Start with these values, you should get comfortable with this, and then go for these values 180, 270 and 360. With the use, you will be able to learn these automatically, means you will not be directly learning it or get comfortable in converting it as quickly as possible. Okay, so learn if possible. If already learned, good thing, it will help you to save time in the exam. Okay, but these are the standard angles that is pretty much expected, that will help you to convert them easily, convert any question of radians into degree And because you know the value of sine 30, sine 45, sine 60, okay, sine cos tan basically. So, and pretty much all the other angles that we'll talk about, like these are the angles in the first quadrant only. What about the angles in the second and third quadrant? They are again the multiples of these with positive or negative. That's it. That's why I'll recommend to identify these angles as quickly as possible, that what is the actual value in degrees. So that gives you a basic idea how to convert degree into radian. So radian into degree, you just do the reverse. Suppose I give you one example. Convert into degree. Okay, and I give you one question. Let's say 5 pi by 3. The question is 5 pi by 3. So in order to convert into degree, what do? You multiply 5 pi by 3 with 180 by pi. So pi cancel. This is 60. 60 into 5 is 300. So basically he's talking about 300 degree angle. So okay, more than 270, less than 360. So this is basically fourth quadrant. He's talking about the fourth quadrant angle. Identification of the quadrant is also very important. That's why I gave you this. Okay, so by looking at any angle in degree, you should be knowing it that in which quadrant it is. Okay. Now also, since we have done this degree and radians, while learning these standard values 0, 90, 180, 270, 360, I'll recommend that you go for some same values in radians. So 0 is 0. This is also known as pi by 2. This is also known as pi. This is also known as 3 pi by 2. And 360 is known as 2 pi. Okay. So you should be comfortable with that also. Pi by 2, if every time I say pi by 2, you should be imagining 90 degree. Pi, 180 degree. 3 pi by 2, 270. 2 pi is 360. All right. You'll see how these will be very useful to save time. Okay. All right. Now let's start with some basic questions of degree and radian. Okay. These are the standard values I'm talking about, but not necessarily you will be always getting some standard values. What if you get a question based in which it's not talking about the whole degree itself? One second. All right. One thing else you need is like 1 degree, okay, is equal to 60 minutes. This is a conversion. Okay, this is degree. This is the symbol for dash. Simple dash means minutes. Remember, this is not the unit of time. This is unit of angle. If you remember something from geography, Tropic of Cancer, Tropic of Capricorn were there. So 23 degrees something minutes were there. Okay, those are latitude, longitude. So suppose I have to express 1.2 degree or 1.5 degree. So that fractional part of degree can be represented in terms of minutes. So 1 degree is 60 minutes. This is conversion. Like 1 meter is 100 centimeter. Same way, 1 minute is 60 double dash, that is second. Okay, as simple as that. Now let's see how it's so useful. Let's take this, look at this question. This is 40 degree 20 minutes, convert into radian. Now I told you, in order to convert into radian, you multiply degree with pi by 180 degree. But what is the problem right now here is this 20 minutes, 20 dash. So 40 degree is okay. I have to convert 20 minutes into radian. Sorry, into degree first of all. So this is 40 degree and this 20 minutes. So this is 40 degree plus 20 minutes. So plus 20 minutes can be converted into degree by dividing it by 60. Okay, since 1 degree is 60 minutes, so 1 minute is 1 by 60 degree. Okay, so divided by this, you will get the degree. That is 40 plus 1 by 3. If I take the LCM, I get 121 by 3 degree. All right. Yeah. So 121 degree. Now 121 by 3 degree. If I have to convert into radian, I have to multiply by pi by 180. That's it. So just multiply by pi by 180. So 121 by 3 into pi by 180. Okay. Yeah. 121, 180, 11 multiple, no? So it cannot cancel. So let it be like this. 121 pi by 180 into 3 is 540. Okay. So that's your answer in radian. Okay. Need more space for this. All right. Now, reverse of it. You have to convert radians to degree. Okay. So we also know that 6 radian, if I want to convert into degree, I have to multiply by 180 by pi. So 6 into 180 by pi, 180 by pi. That will be in degree. But the problem is, earlier when I gave you this question, convert into degree, there was pi present, so pi cancelled. This time there is no pi. So what do we do now? Because answer of degree is never in terms of pi. You see 30 degree, 60 degree, but you never see pi in terms of degree. Sorry, pi in degree. Huh? So 6 into, we'll have to put the value of pi, I think 180 by 22 into 7. That will be your in degree. Okay. So 2, this is 3. Sorry, 2 into 11. Okay. So that gives you 540 into 7 upon 11. Okay. What else we can do? We'll have to multiply. Okay. 1 second. So let's multiply. 0, 7, 4, 28, 2. And 7, 4, 28, 2, 35, 37. Okay. So that will be answered in your degree, but you might not get your answer expressed. Your options may not be in terms of this as an answer. They might be giving you answer in degrees and few minutes also. So let's convert this. If I divide this by 11, what do we get? You'll get 3, then 48, so 4, then again 40, then again you'll get 3. Okay, so 343 will be the quotient. Okay, and then the remaining will be remainder will be 7. 3, 48, 447. So 7 will be remainder. So 343, 7 by 11. Convert into mixed fraction. Okay, this is also degree, this is also degree. Now convert this fractional part into minutes. So 343 degree. That's okay. How do we convert degree to minutes? We multiply by 60. Okay. So that is now in terms of minutes. So 343 degree, that gives you 420 by 11 minutes. Again, further we can divide it by this 11. So we get again how much? 3 and 88, and then what do we get remainder as 2? So 38, 2 by 11 minutes. So we can remove the integral part. Okay, this is if they actually give you these kinds of complicated value. So usually they give standard values which are easier to solve, but this is specifically to deal with this kind of calculation. 38 minutes, 2 by 8, 11 is also in minutes, but if I convert into seconds, I have to multiply again by 60. So 343 degree, 38 minutes, 120, and then again you divide it by 11, so 121, so approximately 11. Okay, so your answer is approximately 10.99 something or 11 seconds. I cannot go beyond, I can go actually beyond seconds, but there is no unit defined for that. So right now your answer is 343 degree, 38 minutes, 11 seconds. Okay, so that's your 6 radians in terms of degree, and then minutes, and then seconds. Okay, so the idea to convert any radian to degree is, first of all, multiply by 180 by pi. If the pi cancels, good enough. If it doesn't, put the value of pi as 22 by 7, divide it, get your answer in mixed fraction, remove the integral part, and the fractional part will be converted into seconds. Then again do the same thing, convert it to mixed fraction. Again the fractional part, that is 2 by 11 here, will be converted into seconds. In order to convert degree to minutes, multiply by 60. In order to convert minutes to seconds, again multiply by 60. Okay, so very specific problem. I think this is only one type of problem, so you should not be worried too much about it. If they give you this kind of question, it will be a unique one. It means there will be no variations possible for this. Okay. Plus Trigo goes much more beyond the calculation point of view. Okay. All right. Next question. It's saying there is a circle and central angle is 60 degree length of arc. So I like to introduce a concept of angle with respect to your circles. Okay, sometimes it's better to introduce the concept with the question itself. So theta. If we talk about a circle, see, theta will be some portion of this circle. It will have some radius also, r, and this portion, this is length of arc. Now theta is, remember, you should remember this, that theta is L by r. Okay, it's a formula for angle. So any angles that can be measured in terms of r and length of arc, we divide them. But remember that this formula gives theta in radians. You should know that, because you will be using same units. So usually the angle that you get is always in radian, never in degree. So if angle is given in degree, it's your work to convert into radian. So for this question, theta is given 60 degree. So I have to convert into radian. So first of all, 60 degrees, 60 into pi by 180, that gives me pi by 3 radian. Now I can use this formula, that theta is equal to L by r. What is asked? Radius, na? So I convert the formula for radius. Radius is equal to L by theta. So what is the length? L is 37.4, and this is pi by 3. 3 will go in numerator, and the question says use pi as 22 by 7. So use 22 by 7. 37.4 upon 22. 3 is already there. 7 again goes up. solve the calculation, get your answer. Okay, so if you solve this, 33, this can cancel it, 11 into 2, in decimal you'll get 3.4, then multiply it. So 3.4 into 21 upon 2, that's 1.7 into 21. That will give you your answer. That's 35.7. Okay, and since the length was given in centimeter, so radius is also in centimeter. Okay. Anyhow, this concept is important, that theta is equal to L by R is a formula, and remember that theta is in radian. All right, now extend this. Let's extend this concept further. Is saying there is a minute hand whose length is given, how far the tip moves. So basically again we'll draw a clock. Is saying that this clock length is given as 1.5 and the clock moves 40 minutes. So it came here around like this. Okay. 40 minutes. He's saying what is how far the tip moves. How far means he is asking about this length. So this time he is asking about L. We know the formula theta is equal to L by R. So if he is asking for length, we know the R is 1.5. All we need is theta. If we know this theta, we can calculate. Okay. So the main task to solve this question is how to get the theta. So in 40 minutes, how many degree is there first of all, and then you convert that degree into radian. Your 360 degree is covered in 60 minutes. Okay, so I'll do it like this. Like 60 minutes, you cover 360 degree. Okay. Or you can use directly, if you know that I told you that 360 degree is also known as 2 pi in radian. So now directly go for this. That 60 minutes you cover 2 pi radians. Okay. So in 1 minute you will cover 2 pi upon 60 radian. In 40 minutes, this is unitary method. Okay. 2 pi by 60 into 40. So 2, 3, that gives you 4 pi by 3 radian. Use the formula L is equal to R theta. R is 1.5. Theta is 4 pi by 3. Okay, and the question says use pi as 3.14. So I'm not giving the answer, final answer in that. So this is 0.5, 0.22, 2 pi. So if 2 pi is the answer, so 2 into 3.14. I think the value is getting simple now. 6.28, and it was given in centimeters. So this is also in centimeter. Okay, 3.14. Okay. Last example, based on the simple examples of angles only. Okay, remember this is very specific with angles. The real trigonometry will start after this. Okay. He's saying again this concept that if two arcs have same length in two circles, so this time he's talking about two circles. So there is one circle and there is another circle. Both have same angles. No, angles are different, I think, but length of arc is same. So let's say this is one angle, let's say this is another angle. He's saying this length is same. Okay. He's saying find the ratio of their radius. Let's say this has r1 radius, this has r2 radius. The angle is theta 1, theta 2, but the length of the radius, the length of the arc is same. The formula is theta is equal to L by R. That means L is R theta. So since length in the both situation is same, so I'll say R1 theta 1 should be equal to R2 theta 2. He's asking us to find the ratio of the radius. So R1 upon R2 is equal to theta 2 by theta 1. But the main thing that I taught you that in order to use this formula, again you have to convert always the angle into radian. So this is 65 degree. So 65 into pi by 180. That's theta 2, I think. Sorry, this is theta 1. So the first angle is theta 1. This is theta 2. So first the formula is in theta 2 first, na? So 110 here. And then 65 degree into pi by 180. The reason I generated the formula first, because the good thing is now these two parameters cancels. Pi by 180, pi by 180 cancels. So even if suppose while doing this question you forget to convert degree into radian, you will be saved in this particular question. Not always, because here he's talking about ratio. So that's 5 into 13, 5 into 22. So 22 upon 13 or 22 ratio 13. That's your answer. Okay. So angles effectively has two units, degree and radian. There is one part that deals with theta is equal to L by R. Usually standard questions are based on that. Very few questions will be based on conversion of radian to degree or degree to radian. Very few. And if they will be very specific to these two types only. Okay. All right. That covers your basic of angles. Okay. Now let's start with the trigo. Okay. For that, again, I have to go to the quadrant system. All right. Okay. X-axis, y-axis. Okay. Now, I'm assuming that theta is an acute angle. Even if it is not, for the time being, assume theta to be an acute angle. Okay. So, the first thing that we have to talk about is 90 minus theta. What will it represent? So imagine, okay, this is 0 degree, 90 degree, okay, 180 degree, 270 degree, and then again 360. So I ask you to imagine some small angle theta, let's say 10 degree. So 90 minus 10 will be 80 degree. Now 80 degree will be in which quadrant? It will be in first quadrant. So 90 minus theta will represent first quadrant. Okay. Or you can imagine that 90 is here, minus means we have to move clockwise, plus means we have to move anti-clockwise. Okay. So 90 minus is in first quadrant. Second, we'll have to talk about 90 degree plus theta. So 90 plus, just imagine theta is again 10 degree. So 90 plus 10, 100 degree. More than 90 degree will come in the second quadrant. So now 90 plus theta represents second quadrant. Third, let's imagine 180 degree minus theta. So 180 degree minus theta, let's assume 10 again. 180 minus 10 is 170. Less than 180 degree again comes in second quadrant. So second quadrant can be represented by 90 plus theta also, 180 minus theta also. Fourth, one 180 plus theta. Now 180 plus theta means, let's assume again theta to be 10. 180 plus 10 is 190. So more than 180 will come in third quadrant. Fifth, 270 degree minus theta. 270 minus, again just remove 10 degree, assume theta to be small. 270 minus 10 is 260, so less than 270. Minus means it will be reduced, then it will be less than 270, so that is again third quadrant. Sixth, 270 plus theta. Okay, so 270 plus, so plus means we have to increase more than 270, more than 270, let's say theta is 10, so 270 plus 10, 280, it will be in fourth quadrant. Okay. Plus means clockwise, move further from 270, and minus means move in the move in the clockwise direction. Next, 360 minus theta. So 360 is here, less than 360 will be again here in the fourth quadrant. And if we talk about 360 degree plus theta, so 360 plus 1, let's say 370. Now 370 is not here as such, but imagine this, like 90, 180, then more than 180, keep going, 270, more than 270, keep going, 360, and then more than 360. Again, where do you come? In the first quadrant itself. So this is again first quadrant. I told you that 360 means revolution. So after covering one revolution, you are again starting with the first quadrant, and again the second quadrant, the third quadrant, and the fourth quadrant, same way. Okay. How about minus theta? Okay. What if I just say minus theta? Which quadrant you will assume? So I told you, assume theta to be an acute angle. Minus theta means you have to move in anti-clockwise direction from x-axis. So minus theta will be here. This is minus theta. So minus theta will represent fourth quadrant. This was the first thing that I explained you, negative angle. Okay. All right. Now that we have discussed about the angles in terms of 90 plus 90 minus, 180 plus 180 minus, now comes the rule for conversions. first. If 180 degree or 360 degree is involved, do not change. I'll talk about what I'm talking about, the change. Second rule, if 90 degree or 270 degree is involved, change sine to cos and cos to sine. Double arrow means sine will be converted to cos, cos will be converted to sine. Tan will be converted to cot, and cot will be converted to tan. Sec will be converted to cosec, and cosec will be converted to sec. Third rule, apply positive or negative sign according to quadrant. All right. So these are the rules for conversion. It's not making any sense right now. I'll explain you with this example. But before that, there's one more thing that you should know, but I'll give you mnemonics for that so you don't have to learn that. In the first quadrant, everything is positive, all positive. Means sine, cos, tan. Everything is positive, positive, positive. So everything is positive, all positive. In the second quadrant, only sine is positive. Rest everything is negative. That means cos is negative, tan is negative. I'm not talking about sec, cosec, cot. I'll discuss about that later. Right now, let's focus only on sine, cos, tan, because sec, cosec and cot can be derived from it. In the third quadrant, only tan is positive. Okay. Rest everything is negative. So that means sine is negative, cos is negative, but tan is positive. In the fourth quadrant, apart from cos, everything else is negative. Sine is negative, cos is positive, but tan is negative. Now, how can you learn so much information? There is a mnemonic. This is after. So A means in the first quadrant everything is positive. School. So S means in second quadrant sine is positive. 2. Okay. 2. T means tan is positive. Rest everything is negative. C, cos is positive. So after school to college. So if you remember this mnemonics, it will help you to decide in which quadrant which is positive and which is negative. After school to college. Remember this in terms of quadrant: first, second, third, fourth. After school to college. All positive. Sine is positive, means rest everything is negative. 2. T means tan is positive, rest everything is negative. College. C means cos is positive, rest everything is negative. Okay. After school to college. All right. Now, the purpose was just to solve angles that are more than 90 degree. Let's start with very simple, sine 120 degree. Okay. So sine 120 degree. I can rewrite this as sine 90 degree plus 30 degree. Okay. Now what is 90? For the time being, use this as theta. 90 plus theta. Okay, so look at the first rule. 180 and 360 involved, do not change. 90 and 270 is involved, change. So 90 degree is here, that means you have to change. So change sine to cos. So that will become cos 30 degree. But you have to apply positive or negative. How do you decide that? You decide based on the quadrant. We are finding first of all sine. So this will decide the sine, not the cos that we have written here. We are finding sine. In which quadrant? Second quadrant. 120 degree na? Either you imagine 120 degree directly in second quadrant, or 90 plus theta is in second quadrant. Okay. In second quadrant, sine is, look at this, mnemonics. After school to college, second quadrant, sine is positive. So you don't have to like remember everything here, just remember the mnemonics. After school to college, and imagine S means school. In the second quadrant, sine is positive, everything else is negative, so sine is positive. So we have to solve for cos 30. What is cos 30? So positive value of cos 30, is sine 60 root 3 by 2. Okay. Now, my recommendation, try to avoid 90 degree unless stated in the question itself. You can do the same question sine 120 degree by using 180 degree, and that's my recommendation always. Use 180 degree. If I want to write down in terms of 180 degree, I have to write down 180 minus 60 degree. For the time being, this is your theta. Now 180, if 180 is involved, the good thing is that you don't have to change. So no changing, that means we are solving sine, it will become sine only. So write down directly sine 60. But still the sine will be decided by, positive or negative will be decided by this, that which quadrant? Second quadrant. So in second quadrant, sine is positive. So sine 60, that is again root 3 by 2. Okay. So I will recommend that you use this, because the good thing is that you don't have to change. Sine will become only sine. You don't have to change. All you have to do is judge which quadrant we are talking about, and whether in that particular quadrant sine, cos, tan, whichever is asked, is positive or negative. Okay. So I hope this is clear. Now let's take few more examples to help you understand this. Now it's not necessary every time they will give you angle in terms of degree. I told you, if they want to make questions slightly interesting, they will always use radians. 5 pi by 3. Now there are multiple ways to convert this as quickly as possible. First of all, if you look at this pi by 3, if you know what is pi by 3, just multiply by 5, you can get this. So this is first part now. First part. So sine 5 pi by 3 is 60 degree. Okay. Or you convert this into degree by using normal method also, like 5 pi by 3 into 180 by pi. Pi cancel this, 6 becomes 60, 60 into 5 is 300. You can do this also, or if you remember pi by 3 was 60 degree, 60 into 5 is directly 300. Now if you look at 300 degree, first of all, this is more than 270. So that means fourth quadrant. Okay. Fourth quadrant. Now 300, clearly it is closer to 360 degree rather than 180. I told you use 180 or 360. So rather than using 180, I'll use 360. So if I write down in terms of 360, I have to write 360 degree minus 60 degree. That becomes sine 300. For the time being, this is your theta. And 360. If 360 involved, don't do anything. That means sine 60 degree. Okay. No changes. And just use, that the sine here will be decided by this. You are calculating sine in fourth quadrant. Fourth quadrant is after school to college. college means C. C means cos is positive. That means everything else is negative. That means sine is negative. You can check here also. Sine was negative in the fourth quadrant. So minus 60 degrees. So minus root 3 by 2. Okay. Let's solve few more. All right. Second one. Sine 17 pi. Pi is 180. So directly multiply 180 by 17, or use smarter approach here. What you can do is you can save some time. Oh, I have to talk multiple angles also, no? Let's discuss the second part slightly later. Let's discuss the third part first. Okay. Then I'll talk about the negative angles and everything. Tan 11 pi by 6. So I told you that if you remember these values, you can convert. Pi by 6 is 30 degree. So 30 into 11, you will get directly tan 11 into 30 degree. That is tan 330 degree. Again, it is closer to 360. So tan 360 degree minus 30 degree. Okay. That's your theta. Now 360 is involved, so don't do anything. Means no changes. That means tan remains tan. So tan 30 degree. All I have to do is decide which quadrant it is and decide the positive negative. 330 again, more than 270 degree, less than 360. That's your fourth quadrant. Or you can decide by here also. 360 minus theta was also fourth quadrant. So fourth quadrant. In fourth quadrant, which is positive? After school to college. C. Cos is positive. Everything else is negative. Minus tan 30. That means minus 1 by root 3. Okay. Minus 1 by root 3. All right. Now, I'll explain here only. Let's create here. Need some space here. It's okay. All right. Let's talk about angles more than 360 now. So I'll give you one general rule. First of all, 360 degree was this, one rotation. Another 360 like this. Another 360 is like this. So after moving any multiple of 360 degree, basically you come back to your x-axis, positive x-axis. And after that, again you start from first quadrant itself. So the general rule I'll say here is f of 360 degree into n plus theta is f of theta, or f of 2 pi into n plus theta is f of theta. Now what is this f? This f is for any trigonometric function. That means suppose tan 360 degree into 4 plus, let's say, 30 degrees there. Suppose you can express any angle as like this, 360 degree into 4. That means after 4 revolution, again you move 30 degree. So that becomes tan 30 degree. Means there is no effect of rotation as such, because you land again in the first quadrant. It doesn't matter whether this is 30 or even like 180. For the time being, assume it to be theta. Okay, not 180. Let's take instead of like 30 degree, let's say it was tan 360 degree into, let's say 2 plus, let's say 150 degree. Even if your theta is not acute, for the time being, assume it to be acute and use this, that there is no effect of rotation. 360 into anything is cancelled. So all you are left with is solve tan 150 degree. That's it. So you don't have to worry whether this theta is coming acute or not. All you have to understand is there is no effect of this rotation 2 pi into n or 360 degree into n. Now why I'm writing in 2 pi also, this will save you some time as such, because you know that 360 degree is 2 pi. So that's your rule for multiple angles. Now let's apply this. Okay. Second part was sine 17 pi. I can rewrite this as sine 2 into 8 pi, that is 16 pi plus pi. Okay. Now, sorry, not like this. Sorry. 2 pi into, because I have to use 2 pi, na? So 2 pi into 8, that is 16 pi plus pi, that is 17 pi. Now this is 2 pi into n. It has no effect. That means just remove it. That becomes only sine pi. What is sine pi? Basically sine 180 degree. Now how do we calculate sine 180 degree? Because see, 180 degree, if you look at 180 degree in a quadrant, here it is 180 degree. Now 180 degree exactly is nowhere in the second quadrant as well as in the third quadrant. It is creating the partition here. So where do we consider 180 degree? You can consider it anywhere, doesn't matter. So in order to solve this further, I'll assume it to be sine 180 degree plus 0 degree. If I'm assuming plus theta, that means I'm taking in third quadrant. Doesn't matter. If you want to use, you can use 180 minus 0 also, but I'm taking in third quadrant. Okay, so 180 is used, so no change, so sine 0. And we are talking about 180 plus. Now the problem comes, if you directly consider 180, you will not be able to identify this is which quadrant. Either it is second or third. But again, I told you, doesn't matter. So 180 plus theta, let's assume it to be in the third quadrant. In third quadrant, everything is after school to college, na? So 2, tan is positive, so that means everything else is negative. So minus sine 0, but sine 0 is itself is 0, so that is 0. So there was no effect of this positive or negative effectively. Even if you consider negative sign, there is still not effect. Suppose few students might be thinking like, what if it was sine 180 minus 0? Would that give us different answer? No. You are assuming it to be in the second quadrant, 180 minus theta. So you are considering this to be a second quadrant. Now in the second quadrant, you might think it is positive, sine is positive. So plus sine 0. What difference it is creating here? Sine 0 is still 0, na? So both will give you the correct answer. So suppose you land up to this situation, just assume it to be plus 0 or minus 0, your call. If you are taking plus, you are moving to the third quadrant. If you are taking negative, you are moving to the second quadrant. Won't make any difference in the final answer. Final answer is same. Okay. All right. Last one, cos minus 25 by 4. Okay. Fourth, cos minus 25 pi by 4. Let's first deal with this negative angle. I told you that minus theta is in fourth quadrant. Okay, so for simplicity, I'll write the rule. Sine of minus theta is sine theta, but consider fourth quadrant. Fourth quadrant, sine is negative, so put a negative sign here. Effectively, if you have a negative angle in sine, take out the negative. Cos of minus theta, again fourth quadrant, cos theta. In fourth quadrant it is positive. Cos is positive. So in terms of if you are calculating cos of negative angle, it is pretty much same as calculating cos of positive angle. Okay, tan of minus theta, write down tan theta, and again this is in fourth quadrant. Fourth quadrant tan is negative, so put a negative sign. You can learn these as rules also, or you can understand this how they are working. Okay, minus theta is in fourth quadrant. Fourth quadrant, apply the sign positive negative according to the quadrant. So cos of minus, I can rewrite this as cos of 25/4, because in cos negative signs in cancelled. Okay, so I can write this as cos, this becomes, if I actually divide it and convert it into mixed fraction, this is 6 pi plus pi/4. Okay, let's use the property of rotation. This can be written as 2 pi into 3 plus pi/4. So again, there is no effect of rotation. 2 pi into n, remove it. Cos pi/4. What is cos pi/4? Pi/4 is actually 45 degree. So if you remember this, you don't have to write the step. You can directly say cos 45, that is 1/√2. That's your answer. That's the benefit of learning the angles, standard angles. You don't have to write this step or imagine this step. Pi/4, 45, 1/√2. Okay, fine. I think 2-3 questions. You can attempt this question now. Same idea you can use here for the first two. It's just that now the questions are saying, although it is saying prove, in the exam the same questions will be created and they'll be asked you what is the value coming, and they'll give you 4 options. Okay, and you'll have to find the answer accordingly. So for the time being, I'm not erasing it, so that you know what is the value you are supposed to get. Try to attempt these 2 questions on your own using the same idea. How do you do that? Calculate separately tan 225, calculate cot 405, calculate tan, calculate cot. Okay, I haven't discussed cot, so I'll explain you how to deal with that. Okay, one value I'll tell you how to calculate. Rest pretty much is same. Suppose cot 405 na, so I'll solve this. So first of all, 405, it is closer to 360. So cot 360 degree plus, okay, always use plus for rotation, always use plus. Like this is 765 na, so use 360 into 2, 720 plus something. Never use minus. Again, for this 360 into 2 becomes 720, so you cannot use into 2, so use 360 plus something. Okay, this is coming 360 plus 45. So 360 into 1 basically, no effect. So this becomes cot 45, and cot 45 is 1. I'll solve one more value. This one, cot 675. I'm saying that don't use 360 degree into 2 and then minus something. Avoid this. Instead, use cot 360 degree plus how much you'll get? 675 minus 360, 513, 315. Let it be. So 360 plus theta. Again, no effect of rotation. Cot 315. Now use this again. Cot 360 degree minus 45. Okay, so cot 360 is involved, so no change, so that becomes cot 45. All you have to do is now consider the sine. Now I told you the sign of sine, cos and tan. How do you describe this? First of all, this is fourth quadrant, and in the fourth quadrant, now how do you decide cot? Just think of tan, like cot is what? 1 upon tan, na? So if tan in fourth, what is tan in fourth quadrant? After school to college. Cos is positive, tan is negative. So 1 upon tan means 1 upon negative is also negative. Think like this. If tan is positive, cot is also positive. If tan is negative, cot is also negative. I'll give you a table for this so that you won't get confused at all. Okay. For sine of sec, cosec and cot, cot will have same sign as tan, same sign. So for cot, think of tan. For sec, sec is 1 by cos, so think of cos. And for cosec, cosec is 1 by sine, so sine has same sign. Sign means this sign is, I'm talking about positive and negative. So if I talk about let's say second quadrant and I talk about cosec, so in second quadrant is after school, so sine is positive. If sine is positive, cosec is also positive. In second quadrant, cos is negative. If cos is negative, sec is also negative. In second quadrant, tan is negative, then cot is also negative, like this. Okay, so minus cot 45, so that will give you minus 1. Okay, but you should be very comfortable with the values of 0, 30, 45, 60, 90. Okay, for sine, cos, tan at least. Okay, so these first two questions, try to do it on your own. Okay, same idea. We'll do the third one because third one has a slightly different idea. Okay. Plus I'll introduce one concept from the third question. 24, 55. Let's write down the question first. Cos 24, cos 55, cos 125, cos 204, cos 300 is equal to, he is saying prove it to be 1 by 2, although in MCQs you will get find the value of it. Okay, so any question can be formulated in terms of an MCQ. 24, it's not a standard angle, I cannot do anything about it, so let it be. 55, again not a standard angle, I cannot do anything about it, let it be. 125, again I don't know, but it's in second quadrant, I can use the conversions. So let's use cos 180. So what I have to subtract? Minus 55. Look at this. This is also 55, this is also 55. Something will come out of it. Anyways, again use this. Cos, use 180 plus 24. Good thing, 24 is already there. Cos 300, this is closer to 360, so 360 degree minus 60 degree. Let it be. Let's copy. Cos 24, cos 55, 180 minus theta is no conversion, 180 means no change, cos 55, all I have to do is decide sine. 180 minus, that's in second quadrant, Okay, this is in second quadrant, this is in second quadrant, so cos in second quadrant is negative. Same thing here, cos 24 180 is there, so no change, so it will be cos 24. But what about the sign? This is third quadrant, this is also third, means this is same thing, but either you decide from 204 directly or 180 plus. 180 plus is in third quadrant. Third quadrant, again cos is negative. Last 360, no conversion, no change. 3 cos 60 degree. This is fourth quadrant. Fourth quadrant, this is fourth quadrant, no? 360 minus. Fourth quadrant, again cos is positive, not negative. After school to college, so positive. See, cos 24 cancels. Cos 55 cancels. All you are left with is cos 60. That's 1 by 2. And that was your RHS as such, is equal to your RHS. Anyways, you will not get 2 proof questions in MCQs. So, now what is the conclusion that we can take out of here? First of all, that cos A plus cos B is 0 if A plus B is 180 degree or pi. Now I'll introduce radians also simultaneously so that you don't get fixated with degree only, because the same question can be formulated in terms of radians also. So if you add any two angles and they are supplementary means 180 degree or pi radians, cos A plus cos B is always 0. You can verify that. From here, cos 24, sorry, not this, this one, 125 plus 55, that's 180. Directly I can cancel it if I know this property. But my recommendation is don't focus too much on this property. I'm just telling you that yes, it is a property. But if you know the conversions, you can generate it also. Okay, learn only the properties which are required effectively. Don't learn every property because see, Trigo, if you look at on anywhere for the content, you'll find infinite amount of formulas. For every specific condition, there is a formula. Only learn those formulas which are actually necessary. Okay. Okay. Now last 2 questions for this conversions. Now this is where the concept of that theta 90 plus theta 90 minus theta will be actually used, because the moment you see these kinds of questions, if you haven't not done these kinds of questions, you might get confused what I have to do in this. Okay, and you have to assume x to be an acute angle for this. Okay. First question, let's increase the size for this question slightly. Better. Okay, so I'll just directly convert, otherwise it will take too much time. 2 pi plus x. Okay, first I'm converting this 2 pi plus x. So 2 pi means 360 degree. If 360 degree is involved, what is the thing I told you? That there is no change. Okay, that means cos will remain cos x. Now all I have to do is decide is positive, negative according to the quadrant. Now which quadrant is this? This is 360 plus x. So 360 into 1 plus x. So rotation effect. And what is the effect of rotation? No change. Nothing. So that is cos x only, positive. Okay. Next is cosec. Two pi plus x. Okay. 2 pi plus x again same as this. So just use the same idea. This becomes cosec x and same, no effect of rotation. So cosec x only. Next, pi by 2 plus x. What is pi by 2 plus x? Which quadrant first of all? pi by 2 means, first of all, what is pi by 2? 90. Plus x means plus more than 90, means he's talking about second quadrant. More than 90 is second. Tan 90, whenever 90 degree is involved or pi by 2 is involved, okay, you have to convert. You'll convert tan to cot. So I'll write cot x. Now I have to decide positive, negative according to the quadrant. In second quadrant, we are, first of all, what we are calculating? We are calculating tan. In second quadrant, what is tan? Positive or negative? After school, sign is positive, everything else is negative. So I've converted so far numerator only. It's all about thought process. The question doesn't require you to write too much. All you have to do is think. You can do this in one step, one go. Okay. Same thing. Let's start again. Pi by 2 plus, again, we just discussed this is second quadrant. So sec will become cosec. We have to change. Now we have to decide sign, positive or negative. Okay. Sec will behave same as cos. For deciding positive and negative, we have to consider sign of cos. In second quadrant, cos is after school, na? So cos is negative, so sec is also negative. I'm talking about this rule if you are getting confused. This. For second quadrant, cos is negative, so sec will also be negative. Okay. Then cos x is written, so let it be cos x. Pi plus x. Last. Pi plus. What is pi? 180 degree. Plus x. 180 plus means more than 180 means third quadrant. So he's talking about third quadrant. If 180 is involved, no change. Cot will remain same, cot x. But in third quadrant, we have to decide positive, negative. That means cot has same sign as tan. In third quadrant, after school, 2 college, T. Third one is T, na? So tan is positive, that means cot is also positive. Now cancelling, I think cos x cancel, cosec cancel, cot cancel, negative also cancel, you get 1. You might think the question is very simple, but the option will be given as positive 1. See, if the same question was given in MCQ, how the options will be plus 1, minus 1, let's say 0, D, none of these. Now, whenever you get two options with same as positive and negative, they are very close usually, and you may have a tendency to do this question slightly wrong. Like instead of positive 1, suppose you forget one single sign like there, you'll get negative 1 as your answer. Okay. All right. Second question, again the value you will be getting as 2, but again try to think of this as a question. Like you will be given few options, 0, 1, 2, 0, 1, minus 1, and none of these, suppose none of these is given. So none, for that part, second one, none of these will be the correct answer. Sometimes none of these is also answer. Anyways, so this one I'm giving you as an attempt. Try to attempt it. Okay. For this question, 90, 90. This time they have mentioned degree. You might have problem with this, so I will help you with this now. Second part, I'm only solving this one. Cot 450 degree plus x. How will you do that? Because 360 you know, 180 you know. Fine, 360 you know. Let's use that. I can rewrite this as cot 360 degree into 1 or plus 90 degree plus x. Consider this to be your theta. Now 360 is involved, rotation. What is the effect? Nothing, same. That means cot 90 plus x. Okay. Now use this 90 plus. So first of all 90 is involved, so change. Cot will become tan. Now decide positive, negative. This is which quadrant? 90 plus is in second quadrant. In second quadrant, tan is negative. So cot will also be negative. So minus tan x. Okay. So try to attempt this. Okay. All right. That's it. Oh, that was the last one. No? Fine. So we have discussed how to do conversion. Okay. So a lot of examples I've discussed. Okay. Just don't try to learn this. Try to apply it, because you'll not be able to learn everything in Trigo. We'll be starting with identities in the next class. Identities you'll have to learn, and there are many more identities that you have to go through. Each question will have unique ideas, unique identity itself. Okay, so try to learn this as a rule, not as a formula itself. Okay, mnemonics I have given you, so you can easily use those to incorporate. There is no effect of rotation. If I can write 360 into n plus theta, that is same of f of theta. Means tan will remain as tan theta, cot will remain cot theta. We don't even have to think about the quadrant. We don't have to make this theta as acute. It can be anything. As long as there is 360 involved, 360 into something plus, but remember, it has to be a positive sign, not the negative. That's the key part. Okay, fine. So I'll end the class here. Okay, see you in the next class. All right, good day.